In the triangle ABC, the angle BAC is equal to 90 degrees. D is a point on BC such that AD is perpendicular to BC. Part 1, name 3 triangles that are similar. So I'm going to start by drawing out the triangle ABC. So ABC. And then I'm going to draw out a second triangle, ACD. ACD. And ACD would fit inside ABC. So we have a common side AC or CA at the bottom here. And we know that D is a point on BC. So here's BC. And this is the point D, such that AD is perpendicular to BC. So if we imagine that this triangle was actually inside of this triangle here. But we've drawn them out separately so that we can see more clearly what's going on. So we're going to consider the triangles ABC, so ABC, so triangle number 1, and ACD, so triangle number 2, ACD. The angle BAC, so BAC, this angle here, is equal to the angle ADC, so ADC, so this angle here, and they're both equal to 90 degrees. If triangle 2 fits inside triangle 1, then this angle here, angle C in orange, is a common angle, so they must be equal. So the angle ACD is common. So ACD, so this angle here is equal to this angle here because they're the same angle, they're common. So we've proved that we have 2 angles that are equal in both of the triangles, so the third must automatically be equal as well. So thus the triangles are similar, which means they have 3 equal angles, and the angle ABC, so this angle here in red, is equal to the angle CAD, so CAD, so this angle here in red. So since they're the only remaining angles left in the triangle, they must automatically be equal as well. Okay, now consider the triangles ABC, so triangle 1 again, ABC, and the triangle ABD, so ABD, so triangle 3. So triangle number 3 also fits inside triangle number 1, so ABD would fit perfectly in here, ABD, so this would be where point D is. So triangle 3, which is ABD, would fit right here, ABD. So we're going to consider the triangles ABC, triangle 1, and ABD, triangle 3. The angle BAC, so BAC, so this angle here, is equal to the angle ADB, so ADB, so this angle here. They are both 90 degrees. So we have 90 degrees and 90 degrees. The angle ABD is common, so this red angle here. So they are both the same because this triangle fits into this triangle, so that is actually a common angle. Angle B has to be equal because it's a common angle. So again, we have proven that 2 of the angles are the same, so the third must automatically be the same as well. Thus, these triangles are similar, and the angle ACB, so ACB, is equal to the angle BAD, so BAD. The 3 similar triangles are ABC, ACD, and ABD. So ABC, ACD, and ABD. Part 2. If 2 times AB is equal to 3 times AC, prove that 13 times AD is equal to 6 times BC. So we're given 2 times AB is equal to 3 times AC. So we're going to rearrange this equation to give us AB over AC is equal to 3 over 2. So basically it's the opposite of cross multiply. If we'd started off with this and we wanted to cross multiply, we would have said AB multiplied by 2 gives us 2AB. and AC multiplied by 3 gives us 3AC. So we've just done cross multiply in reverse. So we have AB over AC is equal to 3 over 2. So let's have a look at how we got to this step. So we started off with 2AB is equal to 3AC. So that's what was given to us. Well, we can start off by dividing across by 2 to get rid of the 2 in front of the AB. So we have AB is equal to 3AC over 2. Next, what we can do is break up the 3AC over 2 so that it's 3 over 2 multiplied by AC over 1. AC over 1 is just the same as AC. And since this is 3 over 2 multiplied by AC, if we divide across by AC, we'll get the 3 over 2 on its own. And AB divided by AC gives us AB over AC, and that's equal to 3 over 2. And that's what we wanted. So now that we've rewritten this as this, we need to continue on and prove that 13 AD is equal to 6 times BC. So we're going to consider the triangles ABC, which is triangle number 1, ABC, and ACD, which is triangle number 2, ACD. So by the proportional sides in similar triangles theorem, AB over AD is equal to AC over CD. So AB over AD is equal to AC over CD. So AB corresponds to AD. And we know that these sides match up because we have the red angle on one side of the side and we have the right angle on the other side. And then AC corresponds to CD. So AC corresponds to CD. And again, we know these match up because we have the orange angle on one side of the side and then we have the right angle on the other side. So they match up. And obviously then CB would correspond to CA, but we don't need that right now. So AB over AD is equal to AC over CD. So we're going to rearrange this equation so that we have AB over AC and AD over CD. So let's have a look down here in a bit more detail at how that happened. So we started off with AB over AD is equal to AC over CD. So the first thing we're going to do is cross multiply. AB multiplied by CD is equal to AC multiplied by AD. So we have AB multiplied by CD equals AC multiplied by AD. So we're going to start by dividing across by AC. So it'll cancel out that AC there. So we're going to have AB times CD divided by AC. So we can rewrite that as AB over AC multiplied by CD over 1. And that's all equal to AD. Because remember, we got rid of the AC there. So CD over 1 can be rewritten as CD. And then to get rid of the CD, we're going to divide across by CD. So we're left with AB over AC on the left-hand side. And AD divided by CD gives us AD over CD on the right-hand side. So that's how this becomes this. So we have AB over AC is equal to AD over CD. Now we found out in the last part that AB over AC is actually equal to 3 over 2. So we swap AB over AC for 3 over 2, and that's still equal to AD over CD. So we want to get the CD on its own, so we end up getting CD is equal to 2 over 3 multiplied by AD. So let's have a look at how we did that. So we had 3 over 2 is equal to AD over CD. So we're going to start by cross multiplying. 3 multiplied by CD is 3CD, and 2 multiplied by AD is equal to 2AD. Then we're going to divide across by 3. So we're left with CD on the left hand side, and 2 divided by 3 is 2 over 3, so get 2 over 3 AD. So CD is equal to 2 over 3 AD. So next we're going to consider the triangles ABC, so triangle 1, ABC, and ABD, so triangle 3, ABD. by the proportional sides in similar triangles theorem, AB over DB, so AB over DB is equal to AC over AD, is equal to AC over AD. So again, we're just matching up the corresponding sides. So AB corresponds with DB, so AB corresponds with DB, and AC corresponds with AD. AC corresponds with AD. So we're going to rearrange this equation. So we're going to put AB over AC and DB over AD. So let's have a look at how we did that in a bit more detail. So we started off with AB over DB is equal to AC over AD. So we're going to cross multiply. AB multiplied by AD gives us AB multiplied by AD. And AC multiplied by DB gives us AC multiplied by DB. Next we're going to divide across by AD to get rid of that AD there. So we're left with AB on the left hand side. And then AC times DB divided by AD is going to be AC times DB over AD. Next we're going to divide across by AC to get rid of the AC there. So on the left hand side we have AB divided by AC, which is AB over AC. And on the right hand side we have DB over AD, because remember we got rid of the AC there. So that's how AB over DB become equal to AC over AD becomes AB over AC equal to DB over AD. Okay, so remember we worked out that AB over AC is equal to 3 over 2. So we're going to rewrite this. Instead of AB over AC equal to DB over AD, we're going to have 3 over 2 equal to DB over AD. And then we're going to rearrange to get the DB on its own. So we get DB is equal to 3 over 2 AD. So let's have a look at how we did that. So we have 3 over 2 is equal to DB over AD. So we're going to start off by cross multiplying. 3 times AD is 3AD, and 2 times DB is 2DB. Then we're going to divide across by 2. So get 3AD divided by 2 gives us 3 over 2AD. And then the 2's cancel out, and that's equal to DB. So that's how we got DB equal to 3 over 2 AD. So we've worked out that CD is equal to 3 over 2 AD, and DB is equal to 3 over 2 AD. So this is equation 1, and this is equation 2. So remember, we're trying to prove that 13 AD is equal to 6 BC. So if we add equation 1 and equation 2. So on the left hand side we have CD plus DB. And on the right hand side we have 2 over 3 AD plus 3 over 2 AD. So 2 over 3 AD plus 3 over 2 AD. Now CD plus DB altogether gives us BC. Because if the distance from C to D plus the distance from D to B are put together, then they're going to give us the distance from B to C or from C to B. So that's still equal to 2 over 3 AD plus 3 over 2 AD. Next we're going to multiply across by 6 to get 6 BC, and 2 over 3 times 6 is 4, so equals 4 AD, and 3 over 2 times 6 gives us 9, so 9 AD, and 4 plus 9 is 13 AD. So we get 6 BC is equal to 13 AD, and that's what we were asked to prove.